Optical property effect of electric field on the polarizability. Effect of electric field. Any LC molecule possesses permanent electric dipole. Under an electric field, the molecule tends to rotate until the positive and negative end line up with the electrical field as shown in this figure. This is another example. The positive tends to one direction, negative tends to another end. If it is like this, then positive will go in one direction, negative will go in one direction. This is the waveform of our presentation. Ordinary wave. This is for example of ordinary wave, and this is for the extraordinary wave when field is perpendicular to the axis, and ordinary wave when field is parallel to the axis. Polarizability can be considered as parameter for exploring effect of electric field because the value of polarization depends on the electric. Forces like dispersion and interaction energy within molecule and material are affected by polarizability. In liquid crystal, the molecular polarizability and its anisotropy are important inherent molecular property because it represents the dielectric anisotropy of liquid crystal molecule and intermolecule interaction energy depend on them. This is the given formula. The system chosen for the studies basically have two types of liquid crystal. Two-ring system without linker, that is R2WL. Three-ring system with alkyl linker is shortened as R3EL. Here are the name of the molecules which are studied here. For the two-ring system without alkyl chain, for first molecule, 4-sino-4' pentyl biphenyl. This is the plot of polarization against the electric field. As the electric field increases after a limit, polarizability has a constant value till a particular range and then it falls down. Similar is the case for the also for 2-sino-5 pentyl phenyl pyridine. Another case is 2,4-sino-phenyl 5-pentyl pyrimidine and 5-sino 2,4-pentyl phenyl pyrimidine. In all the cases, we actually saw that polarizability increases to a certain level and then it goes constant for a particular range of electrical field. This clearly signifies that the optical property of this type of molecule will be good enough for this particular range of the electrical field. Similar the case we found for 3-ring alkyl with alkyl linker. There are 4 examples. That 1-phenyl 4,2, 1s4r4, pentyl cyclohexyl, benzene, and all those. As we see, the system is changed, but behavior polarizability with electric field it does not change. And second interesting change is thing is that as the polarizability increases, HOMO-LUMO gap decreases with the electric field. Analysis of molecular charge distribution of respective atom of these molecules reveal that conjugation effect due to increasing electric field. One can see over it. These are another set of molecular charge distribution for different type of molecules. Inference: the variation of homology gap and polarity with electric field bear a common phenomenon. That is, there are two regions, upper and lower, at which polarizability remains almost stable, and a suitor point to these two regions. Homology gap decreases in a uniform manner and then get stabilized. Polarizability as well as homology gap remain stable within a particular range of electric field and around a certain level. Polarizability shoot up above a point due to conjugation. As the electric field is increased gradually, the polarizability attained stability due to availability of large number of mobile electrons. Further availability of mobile electrons due to conjugation also results in decreasing of separation. Polarizability suffers a stiff fall beyond a certain value of applied electric field due to irregular distribution of regions. The possible reason is that the increase in magnitude of field results in conjugation effect whereby electrons prefer to delocalize instead of localized. Presence of more electronegative nitrogen makes derivative less polarizable by countering the effect of cyano group, hence the higher field is required to reach the suitability region. Substitution of hydrogen with different groups such as fluorine, chlorine or cyano affect molecular length as well as the charge distribution, which have direct effect on the polarizability. Now I am going to show some results on the bireferences effect of electric field on bireferences. Optical anisotropy. The Lorentz equation correlating the refractive index of an isotropic medium with molecular probability at optical frequency was modified by considering that internal field in a liquid crystal is equal in all directions, thus producing a semi-empirical equation that correlates macroscopic refractive index with the microscopic molecular polarizability for anisotropic media. This is given by the equation 1, where N1, Ne and N0 is the refractive indices for extraordinary and ordinary rays. Capital N is the number of molecules per unit volume, and N square is the average of refractive index defined as, which is given by the equation 2, and by substituting 2 into 1, the separating NE-NO, we get the following expression. Among the liquid crystal developed so far, most of them have their refractive indexes around 1.45 to 1.8. This means the second term, the square root is greater than 1 but less than 0.24. Expansion of equation 3 into power series requires the modification as given by. Therefore, in last, we get the change in refractive index and its inverse, which is represented by equation 7. If we keep the center of molecule fixed and move the molecule in all directions, it will be subscribed a sphere having diameter equal to the long molecular axis of the molecule. Thus, we have n is equal to 1 by 4, 1 by 4 third of pi r cube. That is the one molecule in volume of a sphere having r radius. Putting this value in equation 8, we get the one inverse of change in refractive index, and the Gaussian 09 gives result in atomic units. So we need to convert the polarizability into electrostatic unit, that is 1 centimeter equal to 6.748 into 10 to the power 24 AU for polarizability, and 1 AU is equal to 1 by 6.748 into 10 to the power 24. Putting this value, we have the change in refractive, and thus we can use question 10 to determining the references for the values of polarizability provided by Gaussian 9 for desired mimetic. These are the names of the molecule with their molecular length, which are studied for the bireferences. That is 16 in total. Bireferences are calculated at the field where the polarizability along x-axis considering as externally in maximum instability region and considering polarizability along z-axis at the corresponding field as ordinary polarizability, and we calculated here in table. We can see the experimental value theoretical using B3 lead. In first case, this is deviation is 40% for B3 lead and 6% for M02X. In second case, B3 lead has deviation 32%, but M06 to X has variation of 0.3%. Similar is the case of the third. Here, the B3 leaf estimates the 4%, whereas M06 to X represent the 31%. And similar is the case. So one can see that molecular geometry devises which method is more suitable for the calculation of bireferences. One can say a set of molecule and see the similar case. Different molecular structure can be studied by different method, and that is giving a rough parameter. This review gives the rough parameter for which type of molecular system, which method is good for presentation and calculation. The estimated reference ranges for the molecule 3, 4, 7, 8 using value of polarization obtained for Bhimrao are good agreement with the experimental data. And molecule 7 gets minimum deviation of 0.6. Estimated by references for molecule 1, 2, 5, 6, 10, 16 using values of polarizability obtained from the M02X are agreement with experimental data. Molecule gives minimum deviation of 0.3%. Inference. Both molecule 5, 6 have pentyl chain, and for both molecule the estimated value for references using M02X are in good experiment. On increasing alkyl chain, as in case of 3, 4, 8, 9, The estimated result using B3 have a good agreement with the experimental data. For molecule 7 having peptide chain, B3 values give the better result for estimated by references, but for substitution of halogen in the benzene ring, molecule 11, the estimated by references using M062X value is close to 1. For all the other molecules without any linker, 1 and 2 have two benzene rings, molecule 12 and 16 have 2 benzene and 1 cyclohexene ring. The estimated by references using M062X value gave good agreement with the experimental data. Now, let's talk about the bireferences, few more things. Variation of bireferences with homologous series. The bireferences decreases with increase in carbon atom of the alkyl chain. The CS asymmetric stretching of correspond to IR absorbance in the benzene ring and improvement of odd for the odd number and fall for the even number of alkyl chain. Tense Cv liquid crystal is even member of NCb series. The higher absorptions in increasing instead of decreasing the tense CVLC, that is the region for sharply reducing bireferences. One can see here the alteration of bireferences by with the variation of alkyl chain studied with two methods. The order parameter. Here is symmetric stretching of benzene ring at a frequency of 1532 centimeter per centimeter is showing higher absorption for odd number and lower IR absorption for even number of alkyl chain. CC symmetric scissoring in benzene ring is responsible for the molecular phases at the frequency of 2266 centimeter per centimeter. The CN atom stretching correspond to absorbance is continual increases, which is accountable for the increase in the order parameter. Here are we can show the plot of the order parameter with increase and homologous series using two methods B3 and M062. Refractive index. The CH atom asymmetric stretching in alkyl chain is continuously increasing. In the 10 CBLC, the refractive index abruptly increases because the CH is asymmetric stretching correspond to the higher absorption is growing instead of decreasing in the benzene ring. The refractive index does not express any even odd effect. It is continual increases. The H atom rocking in the both benzene ring correspond to higher frequency 1532 per centimeter. It increases only in NLC, which is responsible for abruptly increasing the refractive index. The higher spectrum of 10 CVLC also indicate the absorption due to H atom locking to the both ring. Molecular spectroscopy and adverse optical property of HBT liquid crystal molecule. All the optical properties were computed using by applying the electric field in all the direction as shown in this, where X axis represents the molecular axis. The order parameter. The polarizability ordinary polarizability increases and extraordinary decreases under the influence of an external electric field. The positive order parameter for SBT liquid crystal is 0.68 in the present work. The positive parameter of 0.67. The theoretical prediction is very accurate with the experimental impedance. The maximum order parameter for HBT-LC liquid LC is 0.677 and minimum of minus 0.3865. The Y references. The Y references in the nematic phase exhibit between 0.2 to 0.1. The present work also indicates the Y references of nematic phase is 0.1119. The ordinary polarizability increases and extraordinary polarizability decreases with an impact of temperature. The present work indicates the adverse and negative bireferences of SBT-LC molecule. The maximum bireferences of SBT-LC is 0.1119 and the minimum is minus 0.0814. Character angle and magic angle. The magic angle for liquid crystal is 54.7. The present work also indicates the magic angle of HBT-LC is 54.73. The maximum range of director angle is 74.03. The minimum range is 27.56. The director angle is stable for the nematic and sematic phases. Higher spectroscopy of HBT liquid crystal. The CO stretching expresses the maximum absorption because the oxygen atom transfer the exchange of benzene ring during the intermolecular interaction. An oxygen atom transfers the proton to the nitrogen atom during the intermolecular interaction, which is responsible for the maximum transmittance of the molecule. Vibrational mode of HBT liquid crystal. It is divided into two columns. One is frequency per centimeter and mode of vibration. 565, which is CH bagging in benzene. 845, out of plane bagging of hydrogen atom. 976, OC stretching, carbon atom of alkyl chain. 1178, in plane scissoring of the CH atom. 1232, OC stretching, carbon atom of the benzene ring. 1342, CC stretching in benzene. 1426, CH out of plane waving. 1539, CH in plane scissoring in benzene. 1631, CN stretching in plane scissoring of CH atom. 3030, CH symmetric stretching in alkaline chain. 3092, CH asymmetric stretching in the alkyl chain. 3191, CH asymmetric stretching in. Given odd effect of 7OM liquid crystal compound, this is studied under the effect of electric field. As I told you earlier, the long molecular axis is considered as x-axis. Electric field is applied in all the direction, that is the plane parallel to the x-axis, parallel to the y-axis, and parallel to the order parameter. The order parameter of 7OM series sharply decreases with 7O6 molecule exhibited by both method Vitrative and M062X. Because the bond orientation order break rotational symmetry and exhibit symmetric F phase. Experimentally reported, the order parameter of 701 exists between 0.42 to 0.63. In present work, the order parameter for 701 is 0.41, which is indicated by the B3 method. By references. By experimentally calculated by references for 702, 703 is zero point 0.1 and 12 and zero point 0.1. In present work, the by references for 702 and 703 is 0.120 and 0.11. Experimentally calculated by references for 704 and existing between 0.1 to 0.15. In present work by references for 704 is 0.1. The 0.706 liquid crystal molecule decreases the by references because the bond orientational order break rotational symmetry and exhibit symmetric F phase. The F06 and F08 FD not have having a nematic phase, which is the region for the SAR element of the birefringence indicated by the method B3 leaf. Dipole moment. The dipole moment perfectly expresses the even odd effect with increasing length of alkyl chain of the 7OM compound series. In 7OM compound series, the dipole moment increases for the odd carbon number 357 of the alkyl chain and exhibit odd even effect slightly. The dipole moment decreases, the alkyl chain increases. Still, after 707 liquid crystal molecule, the even odd effect does not observe. Still, the dipole moment decreases continuously as the length of alkyl chain. Refractive indexing. The even odd even effect does not observe in the refractive index calculated by the B3 leaf method, while a little bit odd even effect observed in the refractive index calculated by the M062X method. The M062X method expresses a high amount of refractive index as compared to the B3 leaf method. Experimentally reported refractive index of 704 is 1.57. However, theoretical prediction of 704 is 1.57, which is indicated by the B3 method. By references versus order parameter by BM062X method. The M062X method does not have any sharp edge, but the B3 method has a sharp. The 701, 702, 703 and 704 have the same order parameter. After the 704, the order parameter fluctuates with the Y references. The order parameter and Y references of 706 Fc molecules sharply decreases because the bond orientational order breaks rotational symmetry and exhibit symmetric F phase. Even odd effect of homologous ratio NCHBT liquid crystal molecule under the influence of electric field. Transition temperature. Experimentally reported the increase of amount of melting point observed when the number of carbon atom alkyl chain is odd and small changes in rigid core structure lead to the change in attractive and repulsive forces. The transition temperature expresses the even odd effect under the extension of alkyl chain length of NCB steam liquid crystal. The odd carbon number has a higher perspective, however, the even carbon number has the lower perspective. the dipole moment. The even carbon number of alkyl chain expresses higher value of dipole moment, while the odd carbon atom expresses lower value of because the CH bagging and CH twisting frequency increases for even carbon atom number of the benzene ring, but the twisting frequency decreases for odd carbon atom. The CH stretching frequency is also responsible for even carbon atom in the upward direction and odd carbon atom in downward direction. The variation of dipole moment indicate the CH-BT-LC molecule are changing shape and size due to increase in the alkyl. The 9-HBT shows the refractive index sharply increased because the IR absorption found to be very high in 9-HBT-LC by the cause of the CH wagging frequency of benzene ring. The rocking frequency correspond to IR absorption has found to be very high in the tail of 9CBT. The CN stretching correspond to IR absorption is continual increases with for the CBT series, but the CN stretching decreases the NCBT LC battery region for enhanced refractive index. Birefringence. Experimentally reported birefringence decreases with the extension of alkyl chain. In the present work also birefringence decreases and expresses even odd effect due to an increment of alkyl chain length because the CS symmetric and asymmetric stretching correspond to IR absorption increases for the odd carbon number and decreases with even carbon atom number of benzene and cyclohexane ring. Order parameter. The order parameter continuously increases with the increment of alkyl chain length because Cn and Cc atom stretching correspond to the IR absorption continuously and decreases for the NCVT series. The order parameter has expressed an even odd effect with minor deviation. This is the representation of order parameter in 3 dimensions. Magic angle. The magic angle decreases continually with the increased alkyl chain, but the magic angle increased again in 10 CVT. However, NCVT maintained 54.7 magic angle for all series. The magic angle of liquid crystal molecule depends upon the molecular anisotropy. The NCVT liquid crystal series have uniaxial, however, the 9-CHBT is biaxial. The magic angle of 9-CHBT decreases and 10-CHBT increases due to uniaxial behavior of the liquid crystal. Range of director angle. The range of director angle continually increases with extension of alkyl chain. The Cc and Cn atomic stretching contribute to the enhancement of frequency due to the range of director angle increases continually. The maximum director angle continually decreases with the extension of alkyl chain length. The maximum director angle remains constant 55 degrees because the CH bond stretching of benzene ring remains constant for all series. Isotropic polarizability. Experimentally reported pi electron conjugation of phenyl ring with the terminal NCH group gives strong polarizability as comparison with the CN group. The isotropic polarizability increases continually with alkyl chain length because CN atom stretching correspond to higher absorption continuously increases as well as CH twisting frequency of the benzene continuously increases. The strategy of the present review can predict the physical parameter, dipole moment, density of state, isotropic polarizability, intermolecular interaction of unknown molecules. The motivation of this work is to search for new liquid crystals which are suitable under the terahertz application. The DFT method exhibits perfectly electro-optic odd even effect under the applied electric field calculated by given equations. With the help of the methodology, we can predict the optical and sensing property of unknown organic molecule. Molecular polarizability is the most crucial parameter in this work, which is responsible for the optical properties and the organic molecule. These are the acknowledgements. Thank you for your time.